You might have been following NASA's release of spectacular images which are the clearest and deepest that we have seen of distant galaxies thus far. So what is this Webb telescope that actually captured all this information? What is the science of infrared imaging and how was this image even produced? What can we expect from this telescope in the future? These are some of the exciting questions that we'll be looking at in this video. Let's look at this image first. This image is called a deep field in astronomy. A deep field is essentially an image of a point in the sky, a small section of the night sky, wherein after a very long exposure time, the telescope captures information about galaxies and celestial objects at different distances from the Earth, and then we make a composite image of all this information so that we can see all the galaxies that it captured during this exposure time in this single picture, right? Now, what makes the James Webb Space Telescope so exciting is that it's able to capture more detail about the galaxies and celestial bodies. It's able to detect fainter and dimmer objects than Hubble ever was able to, and it's able to detect information about much older galaxies and much older celestial bodies than we were previously able to image. And that's what makes it so cool. And the cooler part than that is that Webb is just beginning its work. The Webb telescope has actually two kinds of infrared imaging technologies. One is the near infrared imaging. That is what we are using right now to capture this image, okay? And this actually, this NIR imaging, it captures objects and celestial bodies that are much closer to the Earth. We have not yet seen images released from the medium infrared technology. The medium infrared technology in the Webb telescope will help us to see even more ancient and distant bodies, and it might require an even longer exposure time, which Webb will release for us in the future, and that's something that we must absolutely look forward to. Now let's look at the James Webb Space Telescope itself. It was launched in September 2021 by US, Canada and Europe, and the development for it started way back in 1990. It is expected to operate for another 5 to 10 years and produce much more information to scientists and commoners alike about space and the entire history of cosmos. So how is it going to get all this information? Let's look into a little bit of fun physics. To understand how the Webb telescope works, let's revisit how a general telescope works. Any telescope actually helps us see very far off objects in the night sky by using a combination of lenses that allow it to take the gathered light and concentrate it so that it's then visible to our naked eye, right? Now, normally on Earth, telescopes use visible light, okay? But we know from 10th standard physics that visible light is not the only light. There is an entire electromagnetic spectrum, which means there are rays of all different wavelengths, right? So there are microwaves which are not visible. There are infrared rays that are not visible again. Why? Because they have very low wavelengths. They have much lower wavelengths than visible light. The Webb telescope uses primarily infrared light to capture its images. Why? Because infrared light, being of higher wavelengths, can easily detect much more distant objects in our universe. The reason is this. Consider an ambulance. When an ambulance is far off, the sound is less, but when it's closer, it becomes much higher and louder to the ears. That's because when the siren is close to you, the wavelength of the sound reaching you is small and the frequency is very high. But as the ambulance goes farther away, the frequency becomes smaller and the wavelength of the sound reaching you becomes longer. It is very similar when light reaches us from galaxies away from Earth. When the galaxy is close by, then the light reaching us is of high frequency and low wavelength. That means that even visible light telescopes such as the Hubble Telescope can detect such light rays and detect the object there. But when light is coming to us from a very far distance, from very old galaxies, then the light, by the time it reaches us, acquires longer and longer wavelengths. That is, it becomes of shorter and shorter frequencies. So long the wavelength becomes that it goes outside the visible light range and into the infrared range. And in that case, only an infrared telescope such as the James Webb Space Telescope can detect the object or the galaxy. That is why James Webb Telescope, being infrared, is helping it to detect very far off objects very clearly and gather information about them. And finally, the information that the telescope got was not an image that we see here. It was actually just a lot of data points that it passed on to the scientists of NASA. The scientists on Earth then took all this information, and since the information was in form of infrared rays, right, it was not all directly visually translatable. So they had to then map it to different colors. Say for example, I have information in form of alphabets and I match each alphabet to a color. A for red, B for blue, C for black, etc. That's the kind of mapping that they had to do with the information that they got, which was a very dynamic information. They had to map it down into visual colors and then make it a pictorial representation, and that is the final image that was released by NASA that you see here. So guys, that's the video, that's the mysteries and the physics of infrared imaging explained to you. I hope that you found this video useful, and if you enjoy such curiosity-provoking videos about our world and about science and math, definitely subscribe to our channel and keep following us to learn more.